Chapter 7.1, Chemical Formulas and Chemical Compounds. This unit will deal with naming. So when we look at chemical formulas, it tells us a lot about that compound. So 1, the chemical formula tells us the relative number of atoms of each kind. So for example, we all know water is H2O. So if I look at this formula, it tells me I have 2 hydrogen atoms and 1 oxygen atom. It tells me that relative number of atoms. If I look at glucose here, I have 6 carbons, 12 hydrogens, and 6 oxygens. So I'm looking at the subscripts to tell me how many of each type of atom there is in that compound. This one specifically is called a hydrocarbon. So that's when our compounds have mostly carbon or hydrogen composing that compound. Another example we could look at is aluminum sulfate. So here I have 2 aluminum atoms, I have 3 sulfur atoms, and I have 12 oxygen atoms. So that outside subscript will distribute to everything in the parentheses. The reason why it's important to know the number of relative atoms is later we'll deal with molar mass. The first type of naming that we're looking at is monatomic ions. So monatomic ions are ions that are formed from just a single atom. So if I look at atoms in group 1, so let's say lithium, sodium, potassium, all the way down, that is group 1. So they each have 1 valence electron. If they lose that 1 valence electron, they're forming a +1 ion charge. If I look at an atom in group 2, so beryllium, magnesium, calcium, strontium, barium, they're going to have 2 valence electrons. So when they lose those electrons, they become an ion with a +2 charge. When I look at group 15, so starting at nitrogen, group 16 starting with oxygen, and group 17 starting with fluorine, each one of these are going to want to gain valence electrons to become more like that noble gas configuration. All right, so 15 will have a charge of -3. All right, group of 16 will have a charge of -2, and our halogens will have a charge of -1. All right, so that's always the case for those ones in those specific groups on the periodic table. The exception here is when we look at our D block elements. So these are the transition metals. Sometimes these transition metals can have different charges, and there's not really a pattern for them. So sometimes it could be +2 or +3, +1, +4, or a combination of different charge. So a common one we'll see is iron 2+, and we also see iron 3+. So there's not really a pattern for these ones. So when we name monatomic ions, so compounds with ions of just 1 atom, we're looking at their nomenclature. So how do I name these? All right, an easy one to look at is simple table salt. So my metal is going to form my cation. So sodium's group 1, so it has a +1 charge. All right, so that cation, that metal, is going to keep the name. So we have sodium. The anion, that's our nonmetal. So that's my chlorine 1- because it's a halogen, is going to drop the ending and change it to "ide." So it now becomes sodium chloride. Some other examples, some other examples. So fluorine will now change to be fluoride. Nitrogen will change to nitride. So when we look at these binary ionic compounds, these are compounds that are composed of 2 different elements. And so the number of positive charges must equal the total number of negative charges, because these compounds are neutral. So for example, still taking our table salt, We have a +1 charge for sodium, -1 charge for chlorine. So that +1, -1 cancels out to 0. So it's a neutral compound. Now, this looks a little bit different when we have ions of different charges. So for example, sodium and sulfur. So sodium, we still know has a +1 charge. Sulfur, since it's in group 16, has a -2 charge. So these two together will not balance out to 0. So if I look at sodium, I need 2 sodiums to cancel out that -2 charge of sulfur. All right, so we can also swap our charges down to become our subscripts. So Na2, all right, from our sulfur, that tells me I need 2 sodium atoms to balance out with my sulfur ion. All right, and then S. All right, so this is my chemical compound formula, and I can name it sodium, all right, because we're keeping the metal the same, and sulfide, all right, because we're changing that ending. All right, so a couple of examples here. We've already looked a lot at sodium and chlorine, so we can ignore that one. We've done that one a couple of times. Next one, so magnesium has a +2 charge because it's in group 2. Bromine, -1 charge because it's in group 17. When I swap down those charges to create my subscripts, or if I look, I need 2 bromines to cancel out that +2 charge. I have magnesium, bromide. All right, I have 2 bromines to cancel out my magnesium. All right, so I can write my name, magnesium. Whoops, that's not supposed to be an I, bromide. Magnesium, bromide. All right, so go ahead, pause the video, try to do the rest of the naming. All right, now you can check your answers. I saved the last one to go over because this one is important to note a difference. So magnesium, we know is a +2 charge. Oxygen is a -2 charge. So when I swap down those charges, or when I look at it, I'm going to create magnesium 2, oxygen 2. Now, when we write our formulas, we always want to do it in the simplest ratio. And so magnesium and oxygen is a 1-to-1 ratio. All right, so if you like that method, or thinking about it, I need 1 magnesium to cancel out with 1 oxygen, those charges, then I have MgO. That's my magnesium oxide. All right, so just depending on which method you want to do, but we get the same result. So that's with monatomic ions. We're looking at group 1, group 2 with one of our nonmetals. Now the naming system changes just slightly, just adding a little thing when we deal with our transition metals. Because remember, those could have different charges. All right, so the important thing here is we're going to use Roman numerals, and that will indicate what charge that ion will have. And we're going to place that Roman numeral in parentheses after the metal name. So for example, we talked about earlier, we have iron 2+ and we have iron 3+ ion. So if I'm writing the name, I would say iron 2. This one I would show iron 3 to indicate which ion of iron that I have. All right, this happens for most of our transition metals, except the ones in our batch 4 that we're memorizing. All right, so zinc, cadmium, silver, those ones you do not need to put the Roman numeral because we already know what their charge is and they don't have multiple charges. Okay, so some other common ones that we'll see, so we'll see copper, chromium, cobalt, iron, this whole list. 2 of these are not transition metals, but they're still going to follow that same Roman numeral system. So these 2 are lead, that's Pb, and tin, Sn. These ones are in group 14. All right, all the other ones, these are our transition metals. So for these ones, we will put those Roman numerals for them. Okay, or if I see the Roman numerals, then I know what charge I'm going to use for my ions and then be able to create my formula. All right, so we're going to do a couple examples going back and forth. First, we're going to look at our Roman numerals if you need a refresher. So here are our possible Roman numerals. All right, for 1, it's going to be a 1. 2 is 2. 3, 3. For 4, it's 1 less than 5. All right, 5 is V. 6 is VI. So 1 more than 5. All right, 7, VII. Okay, so that's our Roman numeral system to indicate the charge of that metal. So for example, we're still going to write our charges above the name. So we have copper 2, telling me that it has a +2 charge. I have bromine, -1 charge because it's in group 17. I can swap down those charges, or I know there's needs to be 2 bromines to cancel out with my +2 charge of copper. So CuBr2, which is copper 2 bromine. All right, remembering we are adding this Roman numeral. All right, and we still put the "ide" at the end of our nonmetal. All right, another example. So iron 2 is a +2 charge, oxygen 2-. So we get FeO. All right, because those 2's will cancel out to be a 1-to-1 ratio. And I get iron 2 oxide. All right, so pause the video and try these other 3 examples here. When you're ready, then you can play it and check your answers. All right, so here are our answers here. Check them off, see how you did. Making sure we have that Roman numeral. We have our "ide" at the end. You show your charges above, all right, to show all of our work. Now, the other way that we'll be expected to look at the naming and the formulas is now going the reverse way. So starting with our formulas and going to the name. All right, so now looking at this first one. All right, well, I don't know which copper this is, all right, but I do know that oxygen always has that 2- charge. And so if I was swapping these charges, well, then they have to cancel out to the simplest ratio. So that would tell me that I would have a 2 here for that subscript. All right, so tracking that back to my copper, I would have to have copper 2+ in order to cancel out with that copper 2- to have that 1-to-1 ratio. All right, so I can name this is copper 2 oxide. All right, next I'm going to try this one. Again, don't really know which cobalt this could be. I do know fluorine has a -1 charge, and it's a 1-to-1 ratio, so cobalt must have a +1 charge to cancel out. So I'm naming it cobalt 1 fluoride. All right, so pause the video, try to do these other ones, then play it when you're ready to check. All right, go ahead, check your answers, make sure they're all correct, make sure you showed your charges for each one, make sure each one has the Roman numeral, and you changed your nonmetal ending to "ide."